Good day, students. We're going to be going over some questions that you're going to be coming across on the midterm exam. So let's write down the title of this lesson. Semester 2 midterm review session 2. Review session 2. Okay, so the first question we're going to go over has to do with operations on vectors. So let's take a look at the first question. Number one, let's decide if C1 is equal to 3 cosine pi over 2 plus I sine pi over 2, and Z2 is equal to 2 cosine pi over 4 plus I sine pi over 4. Find A Z1 dot Z2 and B Z1 over Z2. Okay? Alright, let's take a look at the first part, A, Z1 dot Z2. Z1 dot Z2 is just a product of these two vectors, right? So we're going to have 3 cosine pi over 2 plus I sine pi over 2 multiplied by 2 cosine pi over 4 plus I sine pi over 4. So what is the rule when multiplying complex numbers in polar form? If you look at your formula sheet, the rule is you multiply the radii and you add the angles. Okay, R1, R2, and then cosine theta 1 plus theta 2. So this is simply going to become 3 multiplied by 2. Alright. Times cosine pi over 2 plus pi over 4 plus I sine pi over 2 plus pi over 4. Okay? Alright, what is 3 times 2? Simply 6. And we're going to have cosine. What is pi over 2 plus pi over 4? Let's do that on the side here, okay? So pi over 2 plus pi over 4. Since these are in, we need to find the LCD, so we need to make the denominator the same. So the LCD of 2 and 4 is 4. So times this by 2 top and bottom. So we're going to have 2 pi over 4 plus pi over 4, which is simply 3 pi over 4. So that is your your angle. So if I add pi over 2 plus pi over 4, it's going to become 3 pi over 4 plus I sine 3 pi over 4, the same thing. This is your answer in polar form. Okay? So polar form. Now, what is the answer in rectangular form? So let's figure that out. If the angle is on the unit circle, then we can easily find the exact value. If not, we'll just use our calculators, okay? So the angle that under consideration here is 3 pi over 4. Let's take a look at our unit circle real quick. Unit circle, where's my unit circle? There you go, over here. 3 pi over 4 is right there. It's on the unit circle. So since 3 pi over 4 is on the unit circle, just extract the coordinates, negative root 2 over 2 and root 2 over 2. So 3 pi over 4 is negative root 2 over 2, comma root 2 over 2. Alright, remember the x coordinate is your cosine and your y coordinate is your sine. So I'm going to plug that in here. So I'm going to have 6 times negative root 2 over 2 for cosine plus root 2 over 2i. Alright, distribute the 6 to everything. I'm going to have Negative 6 root 2 over 2 plus 6 root 2 over 2, I, which reduces to negative 3 root 2 plus 3 root 2I, and that's the end of the story. Okay? This is your answer in rectangular form. Rectangular form. Okay? Alright, let's go ahead and try another example. Let's try a situation where we're going to apply the Marbury's theorem. Okay? Write this down. Number 2. Find 1 minus root 3I to the 6th in polar and rectangular forms. Alright. So in order for us to do this, we're raising this to the 6th power. We need to convert it to polar form first so we can use the Marbury's theorem, okay? So polar form needs r and theta. This is rectangular because this is x and y, or a and b. So let's find r first. R is basically the square root of a squared plus b squared. This is a, and this is b. So this is going to become the square root of 1 squared plus negative root 3 squared. Please put the negative under the square in the parentheses to be squared, okay? So this becomes the square root of 1 plus 3, which becomes the square root of 4, and your radius is 2. Now theta is the inverse tangent of d over a, or y over x, okay? So in this case, theta is going to be the inverse tangent of negative root 3 divided by 1, which is simply the inverse tangent of negative root 3. Anything divided by 1 is just that thing, right? Is an identity under division. So let's see what the inverse tan of negative root 3 is. Let me make sure my mode is in a degree form. We're going to have our answer in a degree angular measure. So the inverse tangent of negative square root of 3 is going to yield negative 60. So theta is going to be negative 60 degrees. So let's rewrite this in polar form. So 1 minus root 3I to the 6th power is the same thing as same thing as 2 cosine negative 60 plus I sine negative 60. Raise that the whole story to the 6th power. Okay, so that's what this angle is in polar form. All right, so now that I have it in polar form, we're going to apply the Marbury's theorem. It states that basically when you raise a complex number in polar form to a certain number, that power gets raised to the power of the radius, so it's going to become 2 to the 6th, and the same power is multiplied by the angles. So times cosine, negative 60 times what? Negative 60 times the power, which is 6, plus I sine what? Negative 60 times the power, which is 6. Okay? Alright, now let's simplify that. So what is 2 to the 6th? 2 to the 6th power is simply 64. So we're going to have 64 times cosine negative 360 plus I sine negative 360. Now this is my answer in polar form. Now what is the answer in rectangular form? 360 is on the unit circle, negative 360 is on the unit circle, right? Gotta be there. So let's take a look at what the coordinates of that is. So negative 360 involves just reflecting negative 360 downwards. But since you're on the x, when you reflect negative 360 downwards, you're going to end up right on the same spot where you started. So you end up right here. So it's going to be 1, 0. Okay? So the coordinates for negative 360 is simply 1, 0. Okay? So if we apply here, we're going to have 64 times the x coordinate is the cosine, the y coordinate is the sine, times 1 plus 0i. When we distribute this 64, we're going to have 64 plus 0i, which we can write as 64. Alright, so there goes your answer. This is your answer in rectangular form. Okay? So this is polar form, and down here is rectangular form. Alright, now let's take a look at, we're going to have 2 questions of vectors on the midterm, so let's take a look at 2 examples. Continue example 3. Alright, so example 3, find the value of p minus 2s using the vector diagram below, the vector diagrams below. Okay, let's say that vector p, already done. Let's say vector p is given by a vector like this, like that, as vector p, and vector s is given by that. Okay? Alright, so we're going to look for vector p minus 2s. So how can we do this? Alright, using this diagram right here, what is vector p going to be? What is vector p? Well, we're going to go from tail to tip, right? Vector p involves going to the right how many units? You're going to go to the right 1, you're going to go to the right 2 units to the right, and then you're going to go up 3 units up. So on the x coordinate is 2, and on the y coordinate is 3. So 2 units to the right and 3 units up, that's vector p. And then vector s, remember we can even put a coordinate system at the base just to help you get your orientation together. So I can put a coordinate system here, and put a coordinate system here, and do the same thing for this one too. So tail to tip, how many is down? 1, 2, 3, 4, 5. So vector s is basically negative 5 down. I'm sorry, let's do the x first. So for the x, we're going to go over 1, 2. So 2 to the right, how many down? 1, 2, 3, 4, 5. 5 down, negative 5. Okay? But the question asks for negative 2s. So we have p down. What is negative 2s going to look like? So negative 2s simply means that we're going to distribute negative 2 to s, right? So negative 2 times negative 2 comma negative 5. So distribute the 2 to both of them. That yields negative 4 comma 10. Okay? So we have p, and we have negative 2s. So all we just do is combine them together. So p minus 2s is simply going to be vector p on top, 2 comma 3. Since we already did the negative 2s, we're just going to place this one on the bottom and just combine the 2. So negative 4 comma 10. If we add it downwards, our answer is going to be 2, comma 13, and that's our final result. Alright, so how on earth does this graph look like, negative 2, comma 13? It just simply means you're going to go to the left 2 and down 13. I mean up 13. So let's make a coordinate system down here. Since I'm going up so high, I'm going to put it down. I'm going to go 2, this is the tail right here. So starting from here, I'm going to go 2 units to the right, to the left, sorry, 1, 2 because of the negative, and go up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Bam. So your answer is going to go from 0 all the way to there. Alright, so this long vector you have right here, believe it or not, this vector is P minus 2s. Okay? And we could have done this using the parallelogram rule, but that's fine. So that's basically P minus 2s. Okay? Alright, now let's consider an example where we are just applying the parallelogram rule and finding the sum of two vectors. Okay? So I think this is example 5. Find the sum, the graphical sum of the given vectors. So let's say we have a vector like this, and another vector like that. What is the sum of these two vectors going to look like? So in order to generate what the sum is, all we just have to do is copy this vector up here, and then we'll make a parallelogram. This vector right here, let's call this vector A and call this vector B. Vector B is basically starting from the tail, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 to the right, then 1, 2, 3, 4, 4 up. So 14, comma 4. Alright? So what I'm going to do is I'm going to transpose this vector up here. So I'm going to go 4 up, 1, 2, 3, 4, and 14 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? So draw this vector using a dotted line. What did I just do? I just copied vector B up here. Okay, and if I connect this dot, I have vector A. Now, where on earth is the sum? The sum is what you get when you start from the two tails to the two tips. So right there is the graphical sum. So this one right here, this component, that is vector A plus vector B. Alright? Okay. Alright, so let's go over the last example, which involves finding the roots of complex numbers. Clear this page. Example 6. Write this down. Find the cube roots. Cube roots of 27 cosine 24 degrees plus pi sine 24 degrees in polar form. Okay, so we're just gonna find the answer in polar form. No need for conversion into rectangular forms here. So to do this, since we're looking for all the cube roots, not just the principal roots, we're gonna use a formula. A plus b to the 1 over p, where p is the power, equals r, the radius to the 1 over p, times cosine theta over p plus 2 pi n over p, put this in an angular form, plus pi sine theta over p, plus 2 pi n over p. Okay, this is the formula we're using. It's included in your formula sheet. If you look at the formula sheet that I gave you, we're using this last formula right here. Okay, so in this case, we're going to go from n equals 0, 1, 2. Okay, so it's the three roots starting from 0, 1, 2. That's what we do. Alright, since it's already placed for us in polar form, what we're going to do is directly apply this formula. So in this case, it's going to become the radius, which is 27. We're going to raise 27 to the what? Cube root 1/3. P, in this case, is equal to 3. Alright? Times, we're going to have cosine 24 over p, which is 3, plus 2 pi n over 3. Same thing for the sine part. I sine 24 over 3 plus 2 pi n over 3. Okay? Since we're working with degree, it will benefit us to express this angular measure in degree. We know that 2 pi is equal to 360 degrees, right? So why don't we use that? Alright? 27 to the 1/3 is 3. You can verify that in your calculator. 27 raised to the 1/3 is 3. So it's going to become 3 times cosine 24 over 3 is 8. 8 plus 2 pi, I'm going to apply 2 pi with 360. Okay, so it's going to be 360 over 3. What is 360 over 3? 360 over 3 is 120. 120n plus I sine the same story. 8 plus 120n. Okay, so remember, all I just did here was I replaced 2 pi with 360 and divided it by 3 to give me 120, and then the same story here. So now we're going to start generating our roots, starting with n equals 0. So for n equals 0, we're going to have 3 times cosine 8 plus 120 times 0, close that, plus I sine 8 plus 120 times 0. So since 0 is being multiplied by these two angles, they're gonna go away. So we're just simply gonna have 3 times cosine 8 degrees plus I sine 8 degrees. That goes your first answer for n equals 0. Now let's find our answer for n equals 1. So for n equals 1, same story. We're going to have 3 times cosine 8 plus 120 times 1 plus I sine 8 plus 120 times 1. Okay. Alright, so what does that give us? That gives us 3 cosine 128. Oh, I don't need a parenthesis for that. 3 cosine 128 degrees plus I sine 128 degrees. So there goes the second answer in polar form. Remember, the answers were asked to be given in polar form, not rectangular form, so these are sufficient. Alright, so for n equals 2, same story. We're going to have 3 times cosine 180. Oh, no, I'm sorry. Cosine 8 plus, you guys know the drill. So I just times this by 2, right? Plus 240 plus I sine 8 plus 240. So your final answer is going to be 3 cosine 248 plus degrees plus I sine 248 degrees. Alright? So that's basically how how you do these problems. If you have the formula, you shouldn't have much difficulty executing this algorithm. Alright, so thanks for paying attention to this clip. Remember, it's uploaded on YouTube for your viewing pleasure. Hope this helps you get ready for the exam.